Hello, dearest learner. Welcome to our lesson on determining the conditions that make a quadrilateral a parallelogram. Learning competency. The learner determines the conditions that make a quadrilateral a parallelogram. Quadrilateral is a closed plane figure consisting of four line segments or sides. Examples of quadrilaterals are parallelogram, rectangle, square, rhombus, and a kite. Today, we will focus on the parallelogram. What is a parallelogram? A parallelogram is a quadrilateral with two pairs of opposite sides that are parallel. Which ones are the opposite sides? Let's see. This side is opposite this side, and this side is opposite this side. How about when we say parallel? How are these opposite sides parallel to each other? You see, when you extend this side downward and upward, and extend this one as well, downward and upward, no matter how long it is, they will never meet each other. Same is to the other pair. When we extend the side, whether to the left or to the right, and this side is extended whether to the left or to the right, they will also never meet, cross, or intersect with each other. That's why the opposite sides of a parallelogram are parallel to each other. Here is an example of a parallelogram. This parallelogram is called Parallelogram LOVE. Take note that a parallelogram is named after the vertices of its side. The points here that are color red are the vertices of the parallelogram. So we have here L, O, V, and E. That's why we call this parallelogram as Parallelogram LOVE, naming it after its own vertices. Now we have conditions here that are to be met in order that the parallelogram LOVE or the quadrilateral LOVE will be considered as a parallelogram. The first condition is both pairs of opposite side are parallel and congruent. We have already discussed how to identify the opposite sides. So here we have the opposite sides OV opposite to side LE. And we have the side OL opposite to side VE. Okay, so to indicate that they are paired, let's put a semicolon in between them. Again, the pair of opposite sides are side OV and LE, and the other pair is side OL and side VE. They are opposite each other. So taking into account that this is the side OV and this is the side LE, when extended, they will never meet each other. Thus, they are parallel. Same also with the side Same also with the side OL. Side OL. When extended downward or upward, and the side VE extended whether downward or upward, they will never meet each other. That's why they are parallel. We also have the next condition, that the opposite sides are congruent. What is the measure of our first pair? Our first pair of opposite sides are side OV and side LE. Their measures are 4.74 centimeters. Both are measuring 4.74 centimeters. Do you see this symbol? This symbol is an indication that these sides are congruent to each other or equal in measure. We also have the side OL and the side VE measuring 3.43 centimeters. Both of them are 3.43 centimeters, and they also have this symbol indicating that they are congruent or equal to each other. So take note of these symbols. These small lines here, when you are not given exact measurements, indicates that they are congruent to each other. Same with this one. You have two short lines indicating that this pair are congruent to each other. Now let's go to the second condition. The second condition says that opposite angles are congruent. We know which ones are the sides, so let's proceed to the angles. Okay, let's erase this. Angles in a quadrilateral can be named based on the vertices of the quadrilateral itself, or we can also choose 3 letters, taking into account that the vertex of the angle is in the middle. So for example, we will have angle O is equal, that is similar with angle VOL. Okay? It's the same. Angle L, this angle L is the same with angle OLE. Okay? You see that this vertex here is the angle. So angle O, angle VOL is the same with each other since O is in the middle of angle VOL, and angle L is the same with angle OLE since letter L is in the middle of the angle OLE. So let's use just the vertices. Okay. So we have our angles. Okay, let me write over here. Angle O, angle V, angle E, and angle. So we have our 4 angles. To identify the opposite angles, we must see that those angles are not in consecutive order. To identify the opposite angles, these angles should not be within the same side. For example, for the side OV, the vertices that are included are O and V. So they are not opposite each other, but are adjacent to each other. So the opposite of O is actually E, not V. Okay? Alright. So how about the opposite of V? So the opposite of V is actually the angle L. Okay? So let's write it down. Okay. Opposite angles. Angle O is opposite to angle E, and angle L is opposite to angle V. Okay, so those are the opposite angles. And then let's take into account that they should be congruent to each other. So the measure of angle O is 115.58 degrees. And the measure of angle E is 115.58 degrees. How about angle L and angle V? Both measures 64.42 degrees. Okay, as you can see in the illustration. So again, opposite angles are angle O and angle E, measuring 115.58 degrees. And angle V and angle L are opposite each other, measuring 64.42 degrees. Do you understand? Okay, so that is what makes a parallelogram a parallelogram. Let's continue with the other conditions. Conditions that make a quadrilateral a parallelogram. Number 1. A quadrilateral is a parallelogram if both pairs of opposite sides are congruent. We have taken this up. Again, let us identify the opposite sides. Side AR is opposite to side CE. And the side AC is opposite to side RE. By the way, what is the name of this quadrilateral or this parallelogram? This is your parallelogram CARE. Okay, this is your parallelogram CARE. CARE, named after its vertices. CARE. Understand? Okay. So, since we have identified the opposite sides, let's see if they are congruent. What is the measure of your side AR? Your side AR measures 6.40 centimeters. How about its opposite side? The side CE. Side CE measures 6.40 centimeters. Are they congruent? Yes, they are. How about the other side? Side AC and side RE. The measure of side AC is 3.43 centimeters, and the measure of side RE is 3.43 centimeters. It means that they are congruent to each other. Again, do you see the short lines on the sides? The two short sides here are located on the pair of opposite sides AR and CE. It means that they are congruent to each other. Also, the side AC and the side RE have this short straight line indicating that they are congruent to each other. Do you now see it? Okay, very good. Now, the second condition. A quadrilateral is a parallelogram if both pairs of opposite angles are congruent. First, let's name this parallelogram. What is the name of this parallelogram? This is parallelogram M-A-T-H. Parallelogram math. Where did we get that? From its vertices M-A-T-H. Parallelogram math. Let's identify now the opposite angles. Opposite angles are angle A opposite to angle H. Here they are. And then your angle, angle M is opposite with angle T. Take note that we are using here capital letters. Here is angle M and angle T, opposite to each other. We always use capital letters when naming our plane figures. Okay, so now let's see if the measures of the opposite angles are congruent. What is the measurements of angle A and angle H? The measure of angle A is 120 degrees and your angle H is 120 degrees. How about your angle M and angle T? Your angle M is 60 degrees and your angle T is 60 degrees. So, opposite angles in parallelogram MATH are congruent to each other. Also, if you notice, we have the arrows on the angles like this one arrow, and this one is also one arrow. It means that this angle is congruent to this angle, and this one have two arrows. This one also have two arrows. It means that this angle is congruent to this angle. Okay, take note of those little symbols in your illustrations. Third condition. A quadrilateral is a parallelogram if both pairs of consecutive angles are supplementary. Which ones are consecutive angles? We have here our parallelogram MATH or parallelogram math. For your consecutive angles, you must look for the angles that belong on the same side or line segment. For example, we have here the line segment MA. What are the angles that belong on this line segment? You have your angle M and angle A. Therefore, they are consecutive angles. How about on this side? Line segment AT. What angles do you see? We have your angle A and angle T. Next is your side TH. So your angle is angle T and angle H. They are consecutive angles. And then, for the last side, you have your side MH, or you may also call it side HM. You have your angle M and your angle H. These angles are consecutive angles, since these angles are located on the same sides or line segments. So, how do we determine that they are supplementary? Remember this. Supplementary angles are angles that have the sum of 180 degrees when added to each other. It means that when you add the measure of angle M to the measure of angle A, that will equal to 180 degrees. Let's see, what is the measure of angle M? Angle M measures 60 degrees. How about the measure of angle A? Angle A measures 120 degrees. So when we add 60 plus 120, both are in degrees, that is equal to how much? Yes, that is 180 degrees. So, let's check the others. Angle A is 120 plus your angle T, that is 60, that is still equal to 180 degrees. And then if you add angle T, which is 60 degrees, and your angle H, which is 120 degrees, that is equal to 180 degrees. And your angle M, that measures 60 degrees, when added to your angle H, measuring 120 degrees, is equal to how much? 180 degrees. So that is why the pairs of consecutive angles are supplementary. Angle M plus angle A equals 180 degrees. Angle A plus angle T is equal to 180 degrees. Angle T plus angle H is equal to 180 degrees. And angle M plus angle H is equal to 180 degrees. That is how you determine that angles are supplementary. Again, when do we say that angles are supplementary? When their measures are equal to 180 degrees. For your memory aid, so you have your supplementary, you have beginning with S. In order for you to remember it well, okay, you always write, what is the sum of the measures of the angles when we say that they are supplementary? Or what is the sum of supplementary angles? So, supplementary, and you say that is, okay, 180 degrees. Okay? Again, when you say supplementary, that is 180 degrees. Okay. Yeah. Consecutive angles. Let's review which ones are our consecutive angles. Angle M and angle A. Angle A and angle T. Angle T and angle H. H and M. Okay? They are your consecutive angles. Pairs of consecutive angles in the parallelogram MATH. Condition number 4. A quadrilateral is a parallelogram if the diagonals bisect each other. What is a diagonal? A diagonal is a line a line segment joining two non-consecutive vertices of a polygon. When we say non-consecutive, it means that they are opposite to each other. So, we have here the parallelogram WORD or the parallelogram word. So, the two non-consecutive vertices are O and D and W and R. The diagonal is the line segment joining the two opposite vertices. You have here the diagonal. So you say that you have the diagonal OD and the diagonal WR. Okay, again, diagonal OD and your diagonal WR. So these two line segments bisect each other. It means that they cross each other in a certain point and they divide each other into two equal parts. You see, this symbol again indicating that these two are congruent to each other. We have this symbol also indicating that they are congruent to each other. When we look at their measures, your side here is congruent to this side, and this side is congruent to this side. So, we also have the vertex A here. Vertex A. Okay? So, we say that OA is congruent to AD. And your RA is congruent to AW. So that is how your diagonal bisect each other. So, again, the diagonal is the line segment joining two non-consecutive vertices. This is a diagonal and this is a diagonal. And when they cross each other, they bisect each other or divide each other into two equal parts. So you have the part from O to A measuring the same with A to D. Okay? And R to A measures the same with A to W. That is how your diagonals bisect each other. Condition number 5. A quadrilateral is a parallelogram if each diagonal divides a parallelogram into two congruent triangles. You see, when you have only one diagonal inside the quadrilateral, you will eventually see two triangles. And these two triangles must be congruent to each other. So for the quadrilateral ROSE or quadrilateral rows, you have the diagonal RS. And when you split this parallelogram, you will see these two triangles that are congruent to each other. We have triangle ROS. Triangle ROS. Okay? So your triangle ROS is congruent to triangle. Oh, it should be a triangle. Wait. Triangle RSE. Okay. How do we know that? Due to the symbols like this. So you have one short line here and one short line on the other triangle. It means that this side is congruent to this side. We also have this side being congruent to this side and this side and this side. So they measure the same. These four sides measure the same. Also, we have our angles measuring the same. Angle R is the same with angle S. Angle O measures the same with angle E. And angle R on the triangle RSE measures the same with angle S on triangle ROS. So that makes two congruent triangles. Condition number 5 for a quadrilateral to be a parallelogram. Number 6, we have a quadrilateral is a parallelogram if one pair of opposite sides are both congruent and parallel. With just one pair of opposite sides that are both parallel and congruent, you will have a parallelogram. For example, on the illustration of the parallelogram ROSE or parallelogram ROSE, we have here the symbol that OS is parallelogram to RE, and this symbol indicating the short straight line indicating that OS is congruent to RE. So, just one pair of opposite sides are both congruent and parallel makes this quadrilateral a parallelogram. Let's have an exercise. Direction. Fill in the blank the correct word to complete the conditions that makes a quadrilateral a parallelogram. Number 1. A quadrilateral is a parallelogram if both pairs of blank sides are blank. Number 2. A quadrilateral is a parallelogram if both pairs of blank angles are blank. Number 3. A quadrilateral is a parallelogram if both pairs of blank angles are blank. Number 4. A quadrilateral is a parallelogram if the blank bisect each other. Number 5. A quadrilateral is a parallelogram if each blank divides a parallelogram into two blank. 6. A quadrilateral is a parallelogram if one pair of opposite sides are both blank and blank. Do you remember the answers? Okay, let's see. Number 1. A quadrilateral is a parallelogram if both pairs of blank, that is, opposite sides, are congruent. Did you get the answer? Number 2. A quadrilateral is a parallelogram if both pairs of blank angles, that is, opposite angles, are congruent. Number 3. A quadrilateral is a parallelogram if both pairs of blank angles, consecutive angles, are supplementary. What is the sum of supplementary angles again? That is 180 degrees. Number 4. A quadrilateral is a parallelogram if the blank bisect each other. The diagonals. Number 5. A quadrilateral is a parallelogram if each blank divides a parallelogram into two blanks. The answer? Each diagonal divides a parallelogram into two congruent triangles. And last number, we have a quadrilateral is a parallelogram if one pair of opposite sides are both parallel and congruent. Did you get the correct answers? Very good. How about this one? We have exercise 2, defense. Directions. Study the parallelograms below, then determine what condition that makes the figure a parallelogram. Number 1, what is the name of this parallelogram? Okay, this is parallelogram ABCD. What are the measures of the sides? Side AB measures 6. Side BC measures 7. Side CD measures 6. And side AB measures 7. What do you observe with the measurements of the sides? Okay, so number 1, for your parallelogram ABCD, the condition that makes this quadrilateral a parallelogram is that opposite sides are congruent. Okay, and also they are parallel. So the sides are congruent, opposite sides are congruent, and opposite sides are also parallel. Number 2, we don't have a name for the parallelogram here, so let's just observe. We are given the measures of the angles. So as you can see, we have 115 degrees, 65 degrees, 115 degrees, and 65 degrees. It means that the opposite angles are congruent and consecutive angles are supplementary. Pairs of opposite angles are congruent and pairs of consecutive angles are supplementary. Right? When you add 115 and 65, then that makes 180 degrees. For number 3, we have here the parallelogram EFHG. Okay, so taking these symbols here, we have these short lines indicating that these parts are congruent, and we also have the diagonals. Okay, so what condition is this? This condition is that the diagonals bisect each other. It means that the diagonal FG bisects diagonal EH into two equal parts. Okay? Number 4, you have these symbols, short lines here, and you also have the diagonal. It means that the diagonal divides the parallelogram into two equal or to two congruent triangles. So these are the conditions that makes a quadrilateral a parallelogram. I hope you learned something from me today. May you answer your modules well and understand it well. Thank you very much. Bye-bye.